Okay, now I'm going to explain about the macro mineral magnesium. Okay, magnesium. Okay, next let us discuss about this magnesium. Magnesium is the fourth most abundant and important cation in humans. Okay, it is the fourth most abundant and important cation in humans. The adult body contains about 25 grams of magnesium, 70% of which is found in bones in combination with calcium and phosphorus. Okay, the adult body contains about 25 grams of magnesium, 70% of which is found in bones in combination with calcium and phosphorus. Okay, the remaining 30% occurs in the soft tissues and body fluids. Okay, the remaining 30% occurs in the soft tissues and body fluids. Now let us discuss about biochemical functions of magnesium. It required for the formation of bones and teeth. Okay, magnesium is required for the formation of bones and teeth. Okay, magnesium is the activator of many enzymes. Okay, examples such as hexokinase, glucokinase, phosphofructokinase, adenylate cyclase, ribonuclease, peptidases, okay, cyclic adenosine monophosphate dependent kinases, and alkaline phosphatase, etc. Okay, these are the examples of magnesium. Okay, neuromuscular irritability is lowered by magnesium. Insulin dependent uptake of glucose is increased in normal levels of magnesium. Okay, insulin dependent uptake of glucose is increased in normal levels of magnesium. Magnesium in blood or serum magnesium. Normal concentration of magnesium in blood is 1.8 to 2.82 mg per dl. In about 60% of ionized form, 30% bound with proteins, and remaining 10% is combined with other ions. Okay. Normal concentration of magnesium in blood is 1.8 to 2.2 mg per dl. Okay. In about 60% of ionized form, 30% bound with proteins and remaining 10% is combined with other ions. Okay. Next, dietary requirements. Adult man contains 400 to 420 milligrams, whereas adult women contains 310 to 320 milligrams. Okay, doses above 600 mg may causes diarrhea and central nervous system depression. Okay, doses above 600 mg may causes diarrhea and central nervous system depression. Okay, sources: cereals, nuts, beans, vegetables, cabbage, cauliflower, meat, milk, fruits, potatoes, almonds, and dairy products. Okay. Absorption వచ్చేసినప్పటికీ magnesium is absorbed by the intestinal cells through a specific it is absorbed by the intestinal cells through a specific carrier system. About 50% of the dietary magnesium is normally absorbed. Okay, here magnesium is absorbed by the intestinal cells through a specific carrier system. About 50% of the dietary magnesium is normally absorbed. Okay, high calcium, phosphate, and alcohol disturb magnesium absorption. Okay, parathyroid hormone increases magnesium absorption. Okay, next coming to deficiency disorders, hypermagnesium and hypomagnesemia. Okay, here in hypermagnesium, when serum magnesium level above the normal is called hypermagnesium. Okay, serum magnesium level is above the normal, then it is called as hypermagnesium. Okay, hypermagnesium is seen when excess magnesium is taken orally or parenterally. Okay, it is seen when excess magnesium is taken orally or parenterally. Okay, magnesium intoxication causes depression of neuromuscular system. Okay, this intoxication causes depression of neuromuscular system. This occurs in uncontrolled diabetes mellitus, hypothyroidism, renal failure, and adrenal cortical insufficiency. Okay, this occurs in uncontrolled diabetes mellitus, hypothyroidism, renal failure, and adrenal cortical insufficiency. Hypomagnesemia, when serum magnesium level falls below 1.7 mg per dl, it is called hypomagnesemia. Okay, this occurs due to malabsorption syndrome, prolonged gastric suction, hyperthyroidism, liver cirrhosis, and renal diseases, etc. Okay, this occurs due to malabsorption syndrome, prolonged gastric suction, hyperthyroidism, liver cirrhosis, and renal diseases, etc. Okay, next coming to the point iron. Okay, the next mineral essential trace elements. These are essential trace elements, and this is the micro mineral. Iron is the micro mineral. It is one of the most essential and fourth trace element in the body. Okay, excuse me. It is the one. It is one of the most abundant and fourth trace element in the body. Okay, the total content of iron in an adult body is 3.3 to 5 grams. Okay, in that 70% iron is present in erythrocytes of blood, 5% is present in myoglobin, and 15% is present in ferritin. Okay, next coming to biochemical functions. Iron involves in many functions through the compounds in which it is present. Okay, they are mainly divided into into different groups: heme proteins, hemoglobin or myoglobin, and cytochromes. Okay, catalase, iron sulfur proteins, other non-heme iron containing proteins. Okay, storage proteins and transport proteins. Okay, next let's discuss about heme proteins. Heme is most predominant iron containing substance. Okay, heme లో ఎక్కువ iron containing substances అనేవి ఎక్కువ ఉంటాయి అన్నమాట. It is a constituent of several proteins or enzymes. Okay, next hemoglobin or myoglobin. These are the heme containing proteins having 4 and 1 iron atoms. Okay, these are the heme containing proteins having 4 and 1 iron atoms. They are mainly involved in oxygen and carbon dioxide transport and oxygen states. Okay, they are mainly involved in oxygen and carbon dioxide transport and oxygen state. Next, cytochromes. These are conjugated heme containing proteins mainly located in mitochondria and involved in electron transport chain and oxidative phosphorylation. Okay, these are conjugated heme containing proteins. Okay, cytochromes are conjugated heat containing proteins. Heme containing proteins. Okay, these are conjugated heme containing proteins mainly located in mitochondria and involved in electron transport chain and oxidative phosphorylation. ఓకే, మనకి ఇవి తెలిసిందే. ఇవి సైటోక్రోమ్స్ అనేవి ఎక్కువ మైటోకాండ్రియాలో చూస్తాము. తర్వాత ఎలక్ట్రాన్ ట్రాన్స్పోర్ట్ చైన్ అండ్ ఆక్సిడేటివ్ ఫాస్ఫోరైలేషన్లో కూడా ఈ సైటోక్రోమ్స్ అనేవి ఉంటాయి అన్నమాట. ఓకే, సైటోక్రోమ్ ఆక్సిడేజ్ ఎగ్జాంపుల్ వచ్చేసి సైటోక్రోమ్ ఆక్సిడేజ్, దట్ ఈస్ టూ ఫెరస్ ఆటమ్స్, సైటోక్రోమ్ బి 1 ferrine, cytochrome C and C1 ferrine. Okay, next catalase. It is a heme containing enzyme found in blood, bone marrow, mucous membrane, liver and kidney. Okay, it is a heme containing enzyme. Catalase అనేది heme containing enzyme found in blood, bone marrow, mucous membrane, liver and kidney. Okay, it catalyzes conversion of H2O2 to H2O and O2. Okay, it catalyzes hydrogen conversion of hydrogen peroxide to water and oxygen molecule. Okay, peroxidase is also involved in phagocytosis and bacteria killing. Okay, peroxidase is also involved in phagocytosis and bacteria killing. Next, coming to iron sulfur proteins. In iron sulfur proteins are non-heme iron containing protein, exhibits as Fe2S2, okay, iron sulfur, or Fe4S4 complex. Okay, they are mainly present in electron transport chain complex 3, succinate dehydrogenase and xanthine oxidase. Okay, these are the examples of iron sulfur proteins. And other non-heme iron containing proteins, that means enzymes aconitase and phenylalanine hydroxylase, are involved in tricarboxylic acid cycle and phenylalanine catabolism. Okay, some enzymes like succinate dehydrogenase, ribonucleotide reductase require iron as cofactors. Okay, some enzymes like succinate dehydrogenase, ribonucleotide reductase requires iron as cofactor. Okay, storage proteins and transport proteins. Storage proteins, transport proteins involves ferritin, hemosiderin, and transferrin. Okay, let us discuss about ferritin. It is the iron storage present in liver, spleen, and bone marrow. Okay, it is the iron storage present in liver, spleen, and bone marrow. It stores nearly 4,000 iron atoms. Okay, ferritin stores nearly 4,000 iron atoms. Okay, next hemosiderin. Okay, this it is the another iron storage protein present in spleen and liver. Okay, ఫెరిటిన్ వచ్చేసి లివర్ స్ప్లీన్ బోన్ మ్యారోలో ఉంటుంది. హిమోసిడ్యూరిన్ వచ్చేసి స్ప్లీన్ అండ్ లివర్లో ఉంటుంది. ఓకే, ఇట్ స్టోర్స్ ఐరన్ ఇన్ ఆల్మోస్ట్ లార్జ్ క్వాంటిటీస్. ఓకే, హిమోసిడ్యూరిన్ స్టోర్స్ iron in large quantities. Transferrin is a non-heme iron binding protein. It binds with 2 iron atoms and transport to hemopoietic organs. Okay, it binds with 2 iron atoms. Transferrin binds with 2 iron atoms and transport to hemopoietic organs. Okay, next coming to dietary requirements. Adult man requires 10 mg per day, adult woman requires 18 mg per day, and pregnant and lactating woman requires 40 mg per day, whereas children 30 to 15 years requires 20 to 30 mg per day. Okay, next sources. Rich source organ meats, liver, heart, kidney. Okay, good sources are leafy vegetables, pulses, cereals, fish, apples, dates, dried fruits, and molasses. Whereas poor sources are milk, wheat, and polished rice. Okay, next coming to absorption. Okay, next absorption. Iron is mainly absorbed in the stomach and duodenum. Okay, iron is mostly found in the foods in ferric form in the acidic medium. The iron Fe3 plus is released from food. Okay, in presence of reducing substances, ferric ion is converted to ferrous form. Is important reducing agent. Okay, in blood it is transported by transferrin protein, and excess amount is stored in storage protein, ferritin, and hemosiderin. Okay, next coming to deficiency disorders. Okay, first one is iron deficiency anemia, and the second one is okay, there is only one iron deficiency anemia, and next hemosiderosis and hemochromatosis. Okay, hemosiderosis and hemochromatosis. Next coming to let's discuss about iron deficiency anemia. This is the most prevalent nutritional disorder to world. Okay, here iron deficiency anemia mostly occur in growing children, adolescent girls, pregnant and lactating women. Okay, iron deficiency anemia is characterized as microcytic hypochromic anemia. Okay, it is characterized as microcytic hypochromic anemia. In this condition, RBC is reduced, cell size is small, and hemoglobin concentration is low, that is less than 12 grams per dl. Okay, ఈ మైక్రోసైటిక్ హైపర్క్రోమిక్ అనేమియాలో ఆ కండిషన్లో ఆర్బీసీ కౌంట్ అనేది రెడ్యూస్ అవుతుంది, సెల్ సైజ్ అనేది చిన్నగా ఉంటుంది, హిమోగ్లోబిన్ కాన్సన్ట్రేషన్ అనేది కూడా తక్కువగా ఉంటుంది, దట్ ఈస్ less than 12 grams per dl. Okay, next coming to important manifestations. Okay, low hemoglobin concentration, serum ferritin levels decreases slowly, erythrocytes protoporphyrin increases above the normal level. Okay, anemia persons are apathy. Okay, that means dull and inactive ga untaru. Metabolism is impaired, growth is retarded, loss of appetite. Okay, iron overload can also be an important clinical condition. Okay, it can also be an important clinical condition. This is mainly due to excessive absorption, that means main iron control point. Okay, parental iron therapy. Iron overload is mainly two types, hemosiderosis and hemochromatosis. Hemosiderosis ko chesinappudiki iron overloaded without cell damage, whereas hemochromatosis ko chesinappudiki iron overloaded with cell damage. Okay, next hemosiderosis gurinchi cheptunnanu. This is a less common disorder and is due to excessive iron in the body. It is commonly observed in subjects receiving repeated blood transfusions over the year. Okay, example వచ్చేసి patients of hemolytic anemia, Hemophilia. Iron is a one-way compound. That is, once it enters the body, it cannot escape. Okay. Excessive iron is deposited as ferritin and hemosiderin. Next, coming to hemochromatosis. Okay. Hemochromatosis. This is a rare disease. Okay, hemochromatosis. This is a rare disease in which iron is directly deposited in the tissues, that is liver, spleen, pancreas, and skin. Okay, here hemosiderosis is sometimes accompanied by hemochromatosis. Okay, hemosiderosis is sometimes accompanied by hemochromatosis. Okay, sometimes accompanied by hemochromatosis. Okay, next coming to the point, important manifestations are pigmentation of skin, cirrhosis of liver, pancreatic fibrosis. These are the important manifestations of hemochromatosis. Okay. Next, skin pigmentation is also called as bronze diabetes. Skin pigmentation is also called as bronze diabetes. Okay. Mm, this is the overview of iodine. Next coming to iron, sorry, this is the overview of iron, and next coming to the point, iodine. Okay, and iodine is the important trace element. Okay, it is also an important trace element, and yeah, actually, yeah, it is also in the micro minerals, and these are also micro minerals, and it is a essential trace element. Okay, it is also an important essential trace element, intimately connected with the function of thyroid gland. Okay, it is intimately connected with the functions of thyroid gland. Iodine was first time I discovered by Bernard Cortois in 1811. Okay, it was first time discovered by Bernard Cortois in 1811. The total content of iodine is about 20 mg. In that, most of 80% being present in thyroid glands, muscles, salivary glands, and ovaries. Also contains some amount of iodine. Okay, it also contains some amount of iodine. Biochemical functions. The only known functions of iodine is its requirement for the synthesis of thyroid hormones, namely thyroxine and triiodothyroxine. Okay. Only known functions of iodine is its requirement for the synthesis of thyroid hormones, namely thyroxine and triiodothyroxine. Okay. Next, these hormones are involved in several functions like oxidative metabolism, basal metabolic rate, growth, etc. Functionally, triiodothyroxine is more active than tetraiodothyroxine. Okay, functionally, triiodothyroxine is more active than tetraiodothyroxine. Okay, plasma iodine. The normal concentration of plasma iodine is 4 to 10 mg per dl. Okay, plasma iodine యొక్క normal concentration ఎంత 4 to 10 mg per dl. Okay, most of this is present as protein bound iodine. Okay, most of this is present as protein bound iodine. Next, coming to dietary requirements. Adults requires 100 to 150 mg per dl μg per day, and pregnant women requires 200 μg per day. Okay. Sources. Sources. Coming to sources, seafoods, drinking water, vegetables, fruits, and table salt are the sources of iodine. Next, absorption. Iodine as iodide is mainly absorbed from the small intestine. Okay. Iodine absorption also occurs through skin and lungs. Okay. Iodine absorption also occurs through skin and lungs. Next, coming to the point, deficiency disorders. Okay. Iodine deficiency stimulates the development of goiter. Okay. As earlier we discussed in physiology or endocrinology about goiter. See, this is the deficiency, iodine deficiency. Okay, goiter, the disorders of iodine metabolism, simple goiter and toxic goiter. Okay, it is characterized by abnormal enlargement of thyroid gland. This is mainly due to deficiency of iodine in food materials. Okay, deficiency of iodine leads to low levels of triiodothyroxine and tetraiodothyroxine, and associated with the failure of autoregulation of thyroid stimulating hormone secretion from pituitary gland. Okay, this leads to accumulation of thyroid stimulating hormone and thyroglobulin in thyroid gland and enlargement of gland. Okay, this disorder is mainly seen in geographical regions away from sea coast where the water and soil are low in iodine content. Okay, this disorder is mainly seen in geographical regions away from sea coast, who are away from sea coast where the water and soil are low in iodine content. Okay, this is the overview of iodine. Next, coming to the next mineral. Copper. Okay, copper is the most important trace element. Okay, this is the most important trace element. It is also an essential trace element. Okay, these are also micro minerals. Okay, because it is most important element in the body adult human, containing 100 to 150 mg copper, which is distributed in different organs. Okay, out of which approximately 65 milligrams is found in body. It occurs as erythrocyprin in RBC, hepatocuprin storage form in liver, cerebrocuprin in brain. Okay, copper is the most important trace element in the body. Adult human contains 100 to 150 mg copper, which is distributed in different organs, out of which approximately 65 milligrams is found in body. It occurs as erythrocyprin in RBC, hepatocuprin in storage form, and it is the storage form of in liver, and cerebrocuprin in brain. Okay, next coming to biochemical functions. Role in enzyme action, role in RBC formation, role in malnutrition of elastin and collagen, role in bone and myelin sheath of nerves, copper in blood. These are the biochemical functions of copper. Okay, first let us discuss about role in enzyme action. Okay, copper is an essential constituent of several enzymes. These include cytochrome oxidase, catalase, thyrosinases, superoxidase, dismutase, monoamine oxidases, ascorbic acid oxidases, alpha alanine, like okay, synthase, uricase, phenol oxidase. These are the roles in enzyme action. Okay, next coming to role in RBC formation. RBC formation యొక్క role ఏంటంటే copper is necessary for the synthesis of hemoglobin. That is, copper is constituent of ALA synthesis. Okay, synthase. Copper helps in the utilization of iron for hemoglobin synthesis through ceruloplasmin. Okay, it acts as serum peroxidase catalyze the oxidation of ferrous ion into ferric ion. Okay, the oxidation of ferrous ion into ferric ion. Okay, see here serum peroxidase catalyzes the oxidation of ferrous ion into ferric ion. This helps in the cooperation of iron, okay, ferrous. This helps in the incorporation of iron into transferring for mobilization and catalyzation. Okay, this helps in the incorporation of iron into transferring for mobilization and catalyzation. Okay, next coming to the point, role in malnutrition. Okay, next role in malnutrition of elastin and collagen. Lysyl oxidase is a copper containing enzyme required for the conversion of certain lysine residues. Okay, it required for the conversion of certain lysine residues of collagen and elastin to lysine, which are necessary for cross-linking of these structured proteins. Okay, next coming to role in bone and myelin sheath of nerves. Okay, copper is necessary for formation of bones, okay, and maintenance of myelin sheath of nerve fibers. Okay, here copper is necessary for the synthesis of melanin and phospholipids. Okay, next, copper is a cofactor of vitamin C requiring hydroxylation. Copper increases high density lipoproteins and protects the heat. Okay, here copper increases high density lipoproteins and protects the heat. Okay, next coming to copper in blood. The copper concentration in blood is 100 to 200 mg per dl. Okay, in that 95% is bound with celluloplasmic and 5% is loosely bound with the albumin. Next, coming to the point, dietary requirements. Adults request 2 to 3 mg per day. Infants and children request 0.5 to 2 mg per day. Okay. Sources. Average diet provides 2 to 4 mg per day. Good sources are liver, kidney, meat, egg yolk, cereals, nuts, legumes, and green leafy vegetables. Okay. Here poor sources are milk and milk products. Okay. Next, coming to absorption. Copper mainly absorbed in duodenum by metallothionein, phytate, zinc, and molybdenum. Decrease copper uptake. Okay, copper mainly absorbed in duodenum by metallothionein, phytate, zinc, and molybdenum. Decrease copper uptake. Deficiency disorders. Copper deficiency causes demineralization of bones, demyelination of neural tissue, anemia, fragility of your arteries, myocardial fibrosis, hypopigmentation of skin, and graying of hair. Okay. Copper deficiency causes demineralization of, okay, here copper causes demineralization of bone. Okay. Demyelination of neural tissues, anemia, fragility, okay, fragility of arteries, myocardial fibrosis, hypopigmentation of skin, and graying of hair. Okay. Next, copper deficiency, anemia. Copper is essential for the formation of hemoglobin. Okay, this is the most important. Copper is most important for the formation of hemoglobin. Copper containing enzymes, ALA synthase is the, is a key enzyme in the synthesis. Ceruloplasmin is a plasma protein contains copper involved in the utilization for RBC genesis. Okay, it involved in the utilization for the RBC genesis. Next, copper deficiency leads to microcytic hemochromic anemia. This condition, RBC count is reduced, cell size is small, but hemoglobin concentration is more or less normal. Okay. Next, Menkes disease. Okay. It is also called as kinky or steel head syndrome. ఈ మెంకిస్ డిసీజ్ ఇంకోలా ఏమంటారంటే స్టీల్ హెడ్ సిండ్రోమ్ అని అనొచ్చు, లేదంటే కింకీ అని కూడా అంటారు. ఇట్ ఈస్ అన్ X-linked disorder of intestinal copper absorption. Okay, it is an X-linked disorder of intestinal copper absorption. In this disease, copper is taken up by intestinal mucosal cells, but its passage into systematic circulation is blocked. Okay, in this disease, copper is taken up by intestinal mucosal cells, but its passage into systematic circulation is blocked. Okay, symptoms of this disease are mental retardation, instability body temperature, and abnormal bone formation, susceptibility to infect steely hair. Okay, intravenously administered copper is handled normally by children, but some severe symptoms are not prevented. Okay, intravenously administered copper is handled normally by children, but some severe symptoms lo matra severe symptoms అనేవి prevented are not prevented. Okay, next, Wilson's disease or hepatolenticular degeneration. It is a rare disorder of abnormal amounts of copper metabolism. ఈ విల్సన్ డిసీజ్ ఆర్ లేదంటే హెపాటోలెంటిక్యులర్ డిజనరేషన్ అనేది రేర్ డిజార్డర్ ఆఫ్ అబ్నార్మల్ amounts of copper metabolism అన్నమాట, and is characterized by the following manifestations. Copper is deposited in abnormal amounts in liver and lenticular nucleus of brain. This may lead to hepatic cirrhosis and necrosis. Okay, this may lead to hepatic cirrhosis and necrosis. Okay, here copper is deposited in abnormal amounts in liver and lenticular cells, lenticular nucleus of brain. Okay, this may lead to hepatic cirrhosis and necrosis. Low levels of copper and ceruloplasmic in plasma with increased excretion of copper in urine. Okay, next, coming to the point, copper deposition in kidneys. Copper deposition in kidney causes renal damage. This leads to increased excretion of amino acids, glucose, peptides, and hemoglobin in urine. Okay, this causes renal damage. ఎందుకు కాపర్ డిపోజిషన్ కిడ్నీస్లో జరగడం వల్ల కాజెస్ రీనల్ డ్యామేజ్. దిస్ లీడ్స్ టు ఇంక్రీజ్డ్ ఎక్స్క్రీషన్ ఆఫ్ అమైనో యాసిడ్స్, గ్లూకోజ్, పెప్టైడ్స్, అండ్ హిమోగ్లోబిన్ ఇన్ యూరిన్. ఓకే, intestinal absorption of copper is very high. Okay, that means about 4 to 6 times higher than normal. Okay. Next, probable causes of Wilson's disease. Mainly two defects come true in this case. Okay. Incorporation of copper into newly synthesized, that means apoceruloplasmin to form ceruloplasmin occurs. It is not clear whether the genetic defect is in the structural gene for ceruloplasmin is unable to incorporate copper. Okay, as a result, copper is free in plasma and which easily enters the tissue and gets deposited. Okay, liver unable to excrete copper into bile. Treatment: this is achieved by removing the excess of tissue copper by copper chelating agent like penicillamine. Okay, this is achieved by removing the excess of tissue copper by copper chelating agent like penicillamine. Okay, this is the overview of copper. Okay, thank you.